So section 1.5 is all about solving various different types of equations. My plan was just to split them up with one type per day. So this would be 1.5a. Specifically, we're going to talk about linear equations. Now, this is pre-calculus. This isn't Algebra 1 or Algebra 2. I'm not going to waste your time talking about inverse operations. We all know adding is opposite to subtraction. We all know if you see a plus 5, you're supposed to subtract 5. But what I wanted to do was just sort of give general everyday hints to make your current problem-solving strategies even better. So instead of teaching you guys new things, I have instead tips or hints, if you guys want to call it that. Because the equations that we're going to see isn't just going to be like, 2x plus 5 equals 7 like you saw last year. They may be quite involved. So if a problem looks way too complicated for you, my suggestion is don't solve it. Don't immediately jump into the deep end. Instead, simplify both sides of the equation first. Now, when it comes to solving equations, simplify both sides of the equation, that usually means breaking down parentheses, breaking down exponents, so on and so forth. And the way we do that, break down parentheses, that is with the distributive property. So the distributive property has the power to break down exponents. Property breaks down parentheses, breaks down parentheses. Such a long day. Parentheses. I think that's how you spell it. Yeah. So, even if it's not the correct spelling, you know what I mean. So if you simplify both sides, it should break down into one of the simpler, 2x plus 5 equals 7 problems. If you are faced with a very complicated equation and you just have absolutely no idea what to do, that's probably because you're trying to solve the whole thing. If students have problem solving equations, it's probably because they're trying to run before they can walk. They trip over their own feet by doing 2, 3, 4, 5 different steps at once. My suggestion is do one step at a time. And in relation to this hint, and this is the one thing that kids just absolutely refuse to do, is to write down, I forgot the N. Write down every part of the equation with every step. What do I mean by that? Well, I think a better explanation, a counter example would be a better explanation. You do not have to write this counter example down. I'm going to be erasing it. But let's say I give you a wickedly complicated equation. 5 minus 8x plus 1 minus 4 equals 12x plus 3. I get kids do this all the time. I know I'm supposed to distribute here, so it's a negative 8x minus 8. And then I have this minus 4 here, so that's going to be minus 12. But I got this 5 here, and then that's going to be negative 8x, minus 7. Oh, I got to distribute the 2, so I'm going to erase this. And you guys are all over the place. You're focusing on one side, and you completely ignore these parts of the equation. So my suggestion is when you're solving a problem, write out every single line, the full line, every single step. Yes, it's more writing. Yes, it takes longer, but I promise you it keeps your work organized, and if you do that, the problem basically solves itself. So let's do a proper example, right? Let's make the ugliest, messiest equation we can think of. I don't have one prepared, so this is completely random numbers and letters. Say, I don't know. Let's do a 2x minus bracket 4 minus 3 parentheses 2x plus 4, bless you, parentheses. Let's toss in a plus, I don't know, 9x for fun there. Close the bracket. And you know what? I think we need a minus 8 as well. And let's say that equals, for brackets, maybe a negative 2 minus parentheses. I don't know, 6x plus 3. Let's close the parentheses. Fine. For Alex, we'll close it there. The point is, I'm trying to make this as crazy complicated as possible. Yeah. So, I look at this and I'm going, I don't know what to begin. This is a very complicated problem, so I'm going to follow my hints and techniques. I'm not going to bother solving it. I'm not going to even think about inverse operations until I simplify this guy down. Simplification usually means distribute and combine like terms. I see parentheses within brackets. Order of operations tells us to work inside out. So I'm going to focus on this distribution here. And I have another distribution here. Anything I did not highlight, I'm not even going to try to touch them. I'm not even trying to think about them. But in my next line, I am going to write it down. So even though I don't use the 2x, I write down the 2x. Even though I don't use the minus, write down the minus. Copy the bracket 4. Now I'm at the distribution step. This is where I'm going to write down my result. So distribute the minus 3 gives us a minus 6x minus 12. I did not do anything with the 9x, so I just copy them down. Bracket, copy down the minus 8 equals copy, copy, copy. So I'm literally just copying the whole problem, and I'm only writing down the things that I'm changing, which is the distribution in this case. So it's a minus 6x minus 3. Right. I still have brackets, which means I have more distribution, but let's combine like terms inside the brackets because they're getting a bit complicated. So let's just focus on those. Anything that's not highlighted, I'm not worrying about them. I'm just copying them down. So copy, copy, simplify. So that is a positive 3x minus 8. Minus 8 equals 4. That's a negative 6x minus 5. I still have brackets, which are nothing more than parentheses, so I still have more distribution. So I'm going to distribute this guy, and I'm going to distribute this guy. Anything I don't highlight, just keep copying down. So distribute the negative, gives me a minus 3x plus 8. Minus 8. Distribute the 4, negative 24x minus 20. I still can simplify this guy, combining like terms, so I will. Any part of the equation I didn't highlight, I'm not going to even bother thinking about, just copy them down. So this is negative x, 8's cancel, equals negative 24x. Minus 20. So now I've simplified both sides as much as possible. All the work we've done here, these 4 lines here, has not been about solving whatsoever. It's just about simplifying. But notice we simplified it to a easy peasy example, easy peasy equation. I hope everyone in here knows how to solve this. So the 4 lines above it was probably the hardest part of this equation. The rest should be automatic. But notice those hints there. I rewrote the entire line, every single step. I only focused on parts of the equation. I didn't try to do it all at once. And any part that I did not touch or any part that I did not manipulate, I just copied it down. The work flows, it's neat, it's organized. And I just made this example up on the spot. I didn't know what the answer was from the get-go. But I was still able to solve it by taking it one step at a time. So let's quickly solve this. Add the 24x. Negative 20, and then divide out the 23. X equals negative 20 over 23. Right. So those are my hints for you. Just one step at a time and show your work to make solving equations easy. This was an example where we had a numerical answer because our equation contained numbers. You should be proficient. I should be able to give you equations that have letters all over the place and you still be able to solve it. The steps are still the same. Solve for whatever letter it asks you to solve for. So if I give you something like this, if, I don't know, A equals B parentheses C plus D all over E, right? It's just an equation, no numbers, but it's fine, still an equation. Solve for C. This type of problem is 100% the same idea as the example above. The only difference is I took out the numbers. But what that means is you don't have any like terms to combine. So you still do the inverse operations, you still do the simplification, just leave it all separate, leave it all loose because you can't combine them. So the first thing I'm going to do is I'm going to distribute because I see parentheses there. I'm going to simplify this guy. A equals BC plus BD over E. I'm solving for C, so I see a fraction. So I'm going to get rid of the fraction by multiplying both sides by E. That gives me AE equals BC plus BD. I'm told to solve for C. So anything that does not have a C in it, like the BD, I'm going to get rid of. So I'm going to subtract him. Inverse operations. AE minus BD equals BC. And last, to solve for C, I got to get rid of that B. So I'm going to divide both sides by B. So AE minus BD over B equals C. What an ugly answer. But the question says solve for C. C is by itself. Boom. That's it. You're done. So you do whatever you normally do for solving equations, except you leave things separate because there aren't any numbers. Now, these types of problems, the answers are not unique looking. There are plenty of equivalent expressions depending on how you solve it. I solved it using the hints and tips I gave you before, but you don't have to use my hints and tips, especially if there aren't any numbers, because an alternative way to solve it would have been, oh, I'm solving for C, so let's get rid of the fraction by multiplying the E. I need to get rid of the parentheses, so instead of distributing the B, let's divide out the B. That will free up the parentheses. And then to get C by itself, you subtract the D. This right here is an equivalent answer. Both answers are the same. One is just merged together as one fraction, where the other was split apart. Okay. Yeah. So either way you do it, as long as you're following good math steps, inverse operation, balancing both sides, you can solve this, bless you, however you will. The last type of linear equations I wanted to refresh our memories on are absolute value equations. The reason why I want to talk about absolute value equations is because everything we talked about prior to this, inverse operations, balance both sides, if you see a plus 5, you do a minus 5. If you see those absolute value bars, that's gone. That doesn't work. All the rules of algebra that you know of do not work when it comes to absolute values. What do I mean? Well, let's look at some counterexamples. So bad examples. I see kids doing this all the time, which is wrong. They see a simple linear equation, say absolute value of 2x minus 1 equals 7, and they go, I'm good. I know equations. To solve for x, I got to add 1 and then divide by 2. So they go plus 1 here. Well, guess what? You cannot do that. You cannot add or subtract within an absolute values. Same thing with multiplying, dividing. I see this all the time. Negative 2, absolute value of x minus 3 equals negative 4. Oh, yeah, one of Mr. Vo's tips was if you see a number in front of grouping symbols, you distribute. So I'm going to distribute in here. You cannot do this.
Did you divide it out?
Yeah. So just be wary that when you have absolute value equations, you can't take stuff out of them, and you can't put stuff inside of the absolute value bars. Those walls are like impenetrable force fields. So how the heck are we supposed to solve equations that have these impenetrable force fields? We need a way to break them down. And the thing that can break down absolute value bars is its definition, sort of like, knowing a demon's name. You use the definition of the absolute value bars to get rid of it. Now, if this was Algebra 1 or Algebra 2, I would spend a lot of time coming up with where this came from, but you should have heard this spiel at least once in your mathematical career, definitely if you were in my Algebra 2 class. So I'm just going to give you the definition. By definition, absolute value is defined as a piecewise function because it can spit out one of two things. Whatever I put inside of an absolute value, x, I could get the exact same thing out, or I could get the exact opposite out. That is why most absolute value definition has a plus or minus, because you get the regular thing out or the opposite out. You only get the regular thing back out if you input something that's not negative. You get the exact opposite thing out if you put in a negative. Yeah. Well, that's why they're practicing. They need it. So anytime you have an absolute value expression, you're just going to go ahead and branch off these two possibilities. For example, suppose I ask you to solve absolute value of 3x minus 4 equals, I'm just making this up, 2. Why not? Notice what the definition says. Whatever I put in the absolute value, I could get itself out. So in this example, what's inside the absolute value is 3x minus 4. So according to the definition, I could get the same 3x minus 4 out. But notice the definition also says it is possible to get the opposite of what you put in out. So this absolute value of 3x minus 4 could also give me the opposite of 3x minus 4. All I did was I just followed the definition. Absolute value, same thing out, or opposite thing out. But if we check the original problem says this absolute value could equal 2. Well, if these two guys here, the 3x minus 4 and the opposite of 3x minus 4, stand for the absolute value, we have to keep that statement true. If yellow equals blue, I think, that's blue. If yellow equals blue, I have to still make it say yellow equals blue, yellow equals blue. What do you know? We have two smaller equations without absolute value bars. We can use normal algebra now. So just solve it. This should take like 10 seconds to solve. Add the 4, divide out the 3. In this instance here, for the second equation, some students like to distribute. Others like to divide out the negative. However you want to do it is fine. I'm a guy who likes to divide, so I'll divide out the negative. So that's 3x minus 4 equals negative 2. Add the 4 over, divide out the 3. Easy peasy.
The isolate.
Yeah. Some little heads up, caution, footnotes, whatever you want to call it. This technique, break down the absolute value by using the definition. You can only do that, or rather, I'll phrase it this way. You must isolate the absolute value before applying the definition. I'm going to write an example, but not solve it, because I think you guys get the idea of solving. But what I mean is, let's say we had something like, 2 minus 3 absolute value of 4x plus 1 minus 8 equals, 7. A lot of kids, when they make a mistake, they want to go, I see absolute value. I'm going to branch off into two equations. Well, if you notice, this is our absolute value term. I have a lot of junk on the outside of the absolute value. So before I split off the two equations, I need to get rid of that 2. I need to get rid of that minus 3. I got to get rid of that minus 8. So you guys understand my little hint, my little warning here? Yeah. Okay. Do not apply the definition until you get this guy by itself. Another little warning. If you take a look at this example here, the one that we did together, I just blew through it. Set it up, solve it, boom, got two answers, 2 and 2/3. I patted myself on the back, good job, we moved on. You can typically do that. If you trust that your math steps were correct, your arithmetic is correct, you didn't do like 2 plus 5 is 8 or something, whatever answer you get is whatever answer you get, because this was a simple linear equation. Notice this equation just equaled a regular number 2. However, if you have variables on both sides of the equation, and here's another must statement, you must check your answers. Because it is possible that you get answers through good, valid math steps, but once you plug it back into the equation, it just doesn't work out. And that only happens in this situation if there are variables on both sides. So just be wary of that. If you're solving an equation that has variables on both sides, just take a quick second, plug them back in to check. And the last little caution, warning, tip, whatever you want to call it, there are special cases with absolute value equations. Just like how there are two special cases when you're solving equations, you can get no solution or infinitely many. There are special cases with absolute value equations as well. I guess this is bad grammar. It's not cases, it's case, single. It's a singular case. Because in math, 3 dots, upside down pyramid is because absolute value always gives a non-negative answer. Whatever you put inside of absolute value, you're guaranteed to get either 0 or a positive number out. It will never give you a negative answer. Any equation of the form absolute value of stuff equaling a negative is no solution. Right. Just a little heads up there. However, as the first little hint, warning, whatever says, you really can't declare no solution until the absolute value is by itself. A lot of students are careless, and they go something like this. They see something like -2, absolute value x minus 4 equals -10. Oh, I remember Mr. Vo said if it equals negative, I'm immediately write no solution. But this is wrong because the absolute value is not isolated. If I get rid of this -2 by dividing, x minus 4 equals +5. Hey, now it becomes a regular equation that we can solve. So just a little warning, do not declare no solution until the absolute value is by itself. And that's it for our refresher on linear equations. Just take it slow and steady, one step at a time, show all of your work, and just be careful with absolute values. That's 1.5. Hey. The pain that students experience.